Okay, 2.1 notes. We're going to learn about functions today. Functions. So a function is a relation in which each element of the domain is paired with exactly one element in the range. So our domain is going to be our x values, and our range is our y values. So super important here, the domain is the x values and the range is the y values. We have three different types of functions. So we have one-to-one, which each element of the domain pairs to exactly one unique element of the range. A function is onto if each element of the range corresponds to an element of the domain. So here, if you notice the difference, one-to-one, for every single thing in the domain, it has its own thing in the range. Onto, we have two things in the domain that point to one thing in the range, so that makes our function onto. So when two things in the domain have the same range. And then a function is both one-to-one and onto when each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element of the domain. So when everything is lined up exactly, it is both one-to-one and onto. So these are three types of functions. In this section, we're going to be determining whether what we're given is a function or a non-function. So a non-functions have at least one x value with two or more y values. So if we had our domain, so let's say this was our domain and our range. We had 1, 2, 3, and 1, 2, we could say 0. If we had one number in the domain that points to two numbers in our range, this would be not a function. So you can't have two y values for one x value. So can't have two y values for one x value. The first slide. Look, our onto has two numbers in our domain that point to the same in our range. So let's look at our first example. We need to state the domain and the range and determine if each relation is a function.
Carter, can you go back up?
All right, so we said our domain was our x values and our range is our y values. So here we have coordinate points in our set. So we know the first point is going to be our x and the second one is the y. So the first value on our coordinate point is our x and the second one's the y. So in each of these, we label the first one as our x and the second as the y. So our domain is going to be the set of all x's. So we have -6, -5, -3, -1, and +6. Now our range is going to be all the y values. So all of the second term. So we have -1, -9, -7, +7, and -9. Do we have any numbers that repeat in our domain or in our range?
Yeah.
-9.
Yep, -9 repeats. So we don't need to write it if it repeats. So we're going to take out that last -9. So our domain, or our range, is just -1, -9, -7, and +7. So we don't write it if it repeats. So now we need to determine if our function, if our relation that was given is a function. So what does -6 go to? So in the last one, you saw how we had the arrows that point our x to the y. What does -6 pair with in our range?
-1.
-1. So we have a pair here. What about -5? What does that go with?
Both -9, so it's not a function.
-9. We don't know if it's not a function yet, because right now, the only thing that makes it not a function is if we had one x value, one number in our domain that goes to 2 numbers in our range. So right now, everything has a pair. So let's look at -3.
Wouldn't it have been like -9 as well, since there were 2 -9?
We'll get there. We'll get there. So let's look at -3. So what does -3 pair with?
-7.
-7. What about -1? +7. And then 6 pairs with -9, so that goes here. So looking back at our examples on the last page, we have 2 x values that point to the same y value. So we don't have 2 arrows coming out of our domain, out of like one thing of our domain, so this would be a function. So this is a function. What would make it not a function is if we had, let's say, if -1 had 2 things, 2 y values for it. But right now, everything in our domain has one range. So this is a function, but what type of function would this be? Would it be one-to-one or onto or both?
Onto.
It's onto. So if we go back to the next, on this one, we have 2 numbers in our domain, -5 and 6, that point to the same number in our range. So this would be a function, and it is onto. Any questions here? All right, let's look at our next example. So here we're doing the same thing, but the information's given to us a little bit differently. We need to find our domain and range and then state if our relation is a function. So first thing we're gonna do is write our domain. So this is all of our x values. So what are our x values here?
2, -1, -2, -1, 2.
Well, we already said -1, so we don't need to write it again. And then we already said +2, so we don't need to write it again. So we don't write it if it repeats. So our domain only has 3 numbers in it. Now we're going to write our range. What numbers go into our range?
-2, -1, 0, 1, 2.
Perfect. Now we need to determine if it's a function and what type of function if it is. So what does 2 in our domain pair with?
-2.
-2. What else does it pair with? Look, we have 2 in our domain that goes to -2 and +2 in our range. So if we see these 2 here, so we have 2 y values for this one x value. So would this be a function?
No, it's not compatible.
Right, it
Not
is
functional.
not a function. Because we can't have 2 y values for one x value. For -1 also, this goes to -1 and 1, so this would also make it not a function. But once we have one x value that points to 2 y values, it automatically is not a function.
So wait, you have 2x value for one y value?
Yeah, like in the last one, how we had 2 and 3 in our domain. And then we had, like, let's just say 1 in our range. We can have 2 domains that point to 1 in the range, but we can't have 1 in the domain that points to 2 in the range. So you just can't have 2 arrows coming out of one number in the domain.
Okay.
All right, let's look at our next example. So we're going to skip 1a for now, but we're going to come back to it. Let's look at 1b. So again, we need to state the domain and range and determine if it is a function. Here, for 1b, it gives us all the numbers in the domain, and it gives us all the numbers in the range, so we don't need to list them again. Would this be a function? Yes or no?
Yes, and it's onto.
Yes, and it is onto because we see that we have -1 that points to 6 and 1 that points to 6. So since we have 2 in the domain that point to 1 in the range, it would be onto.
I gotta leave. I'm gonna have to take mom to the hospital. I don't know if I'll be able to practice. I might. It's all settled on thing.
All the groups are? Okay, I'll take care of it, so.
I'm gonna try and come back out. The swelling and everything's not going down right. It's been like 2.5 weeks. So it was not a kidney, so.
Keep praying for her.
Thanks, man.
Love you, CP.
All right.
So just think to determine if it's onto, you have 2 that are on the number in the range. So that's just a little trick to determine if it's onto. You have 2 that are on it. And let's use the vertical line test for 1a. So if we took a vertical line and put it over every single one of these dots, do we have a vertical line that touches 2 dots at the same time?
Yes.
Yeah.
Yep, if we put a vertical line right over here, it touches 2 dots. So would this be a function?
No.
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 Remember, if it touches 2 dots, it's not a function. Not. So this is not a function. It fails the vertical line test because it touches 2 points at the same time. So in the vertical line test, we can only have 1 point touching at the same time. 1 point at a time. All right. All right. We're going to come back to 1A. Yep. All right. So when we have graphs we can use the vertical line test to determine whether a relation is a function. So the vertical line test, if everybody looks at my picture on the screen, you would take a vertical line and just go over the graph. And if we have two y values, 2 points on our graph that touch the vertical line, then it is not a function. So looking at the first one, we take a vertical line, this vertical line, and we just move it over our graph. It only touches one place at our graph at a time, so this would be a function. So the first one is a function. For the second one, when we have our vertical line, this touches the graph 2 points at the same time, so this means that it is not a function. So the vertical line test, you just take a vertical line, go over the graph, and if your graph touches the vertical line at 2 points at the same time, it's not a function. So let's go back to 1b now, or 1a. For these two examples, we need to determine if the graph is a function, so we're going to do the vertical line test. Looking at this circle for our first one, would this be a function?
No.
No, because if we took a vertical line here, it touches the graph at 2 points, so this is not a function. Looking at this one, would this be a function?
Yes.
Yes, if we took a vertical line over this graph, it always only touches 1 point of our graph. So this would be, yes, a function. Okay, so here we have equations that represent functions, and we need to find out how to evaluate the function. So equations that represent functions are often written in function notation. The equation y is equal to 5x minus 1 can be written as f of x is equal to 5x minus 1. So we say, when we see this f and then in parentheses x, we say f of x. So in this little box on the side, it explains that this is read out loud as f of x. And f is just the name of the function. So f is only the name of the function. So this f of x here is just a fancy way of saying y. So it's just a fancy y. So looking at our example here, we're given the function f of x is equal to 2x squared minus 8, and we need to find the value of f of 6. So we see that here, this is the function of f of x. We're replacing this x with the 6. So that means we need to replace the x in our equation with a 6. So we have 2 times 6 squared minus 8. So all we did was replace that x in our equation with the number that it told us to, which is 6. And now we just solve our equation. So we're just solving the right side here. So this f of 6 is just telling us to plug it in, and then we're just going to find a value for that f of 6. So we're going to say f of 6 is equal to some number once we solve it. So we don't do anything with the left side of our equation. All we're doing is PEMDAS on the right side. So what do we need to do first to solve this?
6 times 2.
PEMDAS. So what do we do first?
Exponent.
Exponent. So 6 squared. What is 6 squared?
36.
36. You don't have to yell at me. Just kidding. Thanks for participating. What is 2 times 36?
72.
72. And 72 minus 8?
64.
64. So f of 6 is equal to 64. Any questions here? We only have one example like this one left, and then we are done for the day. Ready for the next one?
Yes.
All right, so we have to evaluate f of negative 3 if f of x is equal to negative 4x minus 8. So what do we need to do first?
Fill in the blanks.
Fill in,
Well,
right, we fill in the x's with negative 3. So we're replacing all of the x's in our equation with negative 3. So f of negative 3 is equal to negative 4 times negative 3 minus 8. What do we do first here?
parentheses.
What are we doing in our parentheses?
Multiplying.
Multiplying. So what are we multiplying?
Negative 4 times negative 3.
And what is negative 4 times negative 3?
Positive 12.
Positive 12. So we have positive 12 minus 8, which is what?
4.
4.
4. So f of negative 3 is equal to 4.